thank you very much for sending in your work to me. It's been really, really useful in seeing what I now need to do to move you on. So first thing I want to do is to go through that do it now task from last lesson, because you all completed it to various different degrees. So we're going to go through it nice and slowly, because I need to make sure you can do all the sums before I give you a test. And I know you're not going to want the test, but sooner we do it, the sooner we get this topic out of the way and moving on. So let's take a look at what I asked you to do last lesson, which is just here. Okay, so the first thing I asked you to do is, what's the relative formula mass of ethene? Most of you did this really well, so well done. So we've got C2H4. Now we know from looking it up that carbon, I've got all of my elemental properties just here. This is way more than you need to know. So I know from looking it up, I don't need to look it up, but carbon has got a mass of 12. So let's do the relative atomic mass of carbon is 12 and of hydrogen is 1. And then we're going to say, how many atoms have we got? I've got 2 of carbon and 4 of hydrogen. Then I just multiply those together, 24 and 4, and then add those two together. So the MR of C2H4 is 28, 24 plus 4. So that was the first one done. Most of you did that brilliantly, well done. What is the empirical formula of ethene? Now, if you remember, empirical formula is the simplest way you can write something. Okay, so we need to look at the factors. Can we factor that down? C2H4. Well, I can either divide them both by 2 and go CH2, or I can say, okay, I have got 2 carbons and I have got 1, 2, 3, 4 hydrogens. So I can split them up. 2 carbons, 1, 2 hydrogens. So for every carbon, I have 2 hydrogens. Whichever way you want to do that is absolutely fine. So empirical formula is CH2. Okay, a lot of you got that. Brilliant. As I say, I'm going through all of it because people struggled at different points. So, a compound contains the following elements: 52.2% carbon, 13% hydrogen, 34.8% oxygen. What's the empirical formula? Let's find out. So the first thing we do is say, which elements do we have? We have carbon, we have hydrogen, and we have oxygen. Now, we want to get as many marks as possible. So if I see a question like this and get really scared, my first thing is going to be, where can I get a mark? It's worth a few marks. What marks can I get? I know I can get a mark for saying what the relative atomic mass is, because I've obviously done something. So whenever you get a question asking about masses or anything like that, always go for this. So from the periodic table, carbon is 12, hydrogen is 1, oxygen is 16. Yes, it is quicker if you know it, but you will have plenty of time in your exam to look it up. Then I say, what do we know from the question? So I know that carbon is 52.2. So this is the percentage or the mass. Whichever they give you, it actually doesn't matter, because the percentage is just how many grams in 100 grams. Hydrogen is 13 and 34.8 for oxygen. Okay, next thing we're going to figure out is we need to do the AR divided by the mass. Okay, for those of you doing higher paper, this is called the mole, the amount of moles. Sorry, wrong way round. Mass divided by the AR, because it's mass over Mr. Moles. So 52.2 divided by 12, just hang on a second, let me get a calculator. Oh, the miracles of modern filming. It's excellent. 52.2 divided by 12 gives me 4.35. 13 divided by 1 gives me 13. You can check that on your calculators if you want. And 34.8 divided by 16 is 2.17. Most of you got at least this far. The next thing to do is divide them all by the smallest. Okay, so the smallest number there is 2.175. I should use all of it as it's only a small number. So 2.175 divided by 2.175 is going to be 1. Any number divided by itself is 1. 4.35 divided by 2.175 is exactly 2. Isn't that lucky? And 13 divided by 2.175, I will just remind you here that if you've been having difficulties, you're always welcome to pause the video and do it yourself. And we get 5.977. You know what? That's as close to 6 as makes no odds. So, what's the empirical formula? C2H6O. Ooh, I don't write the 1. This is chemistry. We never write the number 1 unless we're doing it in sums like this, because, yeah, quite frankly, chemistry is great if you're lazy. Instead of writing oxygen, we write O. Instead of writing 1, we don't bother. Love chemistry. So there we go. This is our empirical formula. We can't get any simpler because we've got 1 oxygen. So we can't get simpler than that. So that compound's MR is 46. What is its molecular formula? Quite a few of you came unstuck here. So what we need to do is say, right, okay, molecular formula. That's going to be, there's going to be a certain number of C2H6Os. Let's figure out the MR of C2H6O. And we're going to do the same thing again. We've got all the ARs. We've got 12, 1, 16. And atoms, we've got 2, 6, 1. So we're going to multiply all those together. 24, 6, 16. Then add these together. Just remember, you're doing 12 plus 12 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 16. That's what you're doing. Multiplying them together just removes the margin of error. If you've got 53 hydrogens, you don't want to put plus 1 53 times. You'll lose count. That's why we do the multiplying. So 24 plus 6 plus 16 is 46. So my MR of this is 46. Now the compound's MR is 46. 46 and 46 are the same. So that means it's going to be C2H6O. So molecular formula is C2H6O. If it had been 92, so if the compound's MR was 92, 92 is twice 46. I can learn that by doing 92 divided by 46. You don't have to have the 46 times table in your head, don't worry. Then it would be C4H12O2. I would just double all those little numbers here. That's all you'd have to do. So, number 5, balance the equation. C4H8 plus H2O. I was really nasty here. I gave you an equation that wouldn't possibly exist in real life because the one that would do it, ethene and water makes ethanol, is perfectly balanced. And I wanted you to have a go at balancing. So I was a bit mean and gave you an impossible equation, but it does balance. Okay, so let's make it balance. So first of all, we're going to do is we're going to get the Lego out and see what we've got. Okay, so I've got my green carbons, 1, 2, 3, 4 on the left and 1, 2 on the right. I've then got purple hydrogens on the left, 8 of them so 8 of them under the butene and 2 of them under the hydrogen. They've changed colour on this side because I didn't have enough purples, so I've made them gold. And we've got 5 hydrogens, but it's C2, H5, O, and there's my red oxygen, H. So I've not got another golden hydrogen there. So there's 6 hydrogens in total. When we're talking about alcohols, we write OH at the end to let us know it's an alcohol, but it's a really nasty thing because then everyone forgets that extra hydrogen, which is why doing dots or doing Lego is really important. And obviously there's an oxygen over on this side as well for H2O. So I look at this and it's clearly unbalanced. This person here has way more than this, the reactant side has way more atoms than the product side. If we go back to the analogy about the restaurant, this one's got loads of food, this one hasn't. They're going to run out of food first. So what are we going to do? The first thing I would suggest we do is we look at balancing the carbon. Now, because we have got 4 carbons on the left, on the reactant side, we also need 4 carbons on the right, on the product side. But I can't just change the formula. What I have to do is do another one of the ethanol, another of that whole molecule. So there's 1 ethanol, and there's 2 ethanols beneath it. So now I've got 4 carbons on each side. Excellent. Problem is, you can probably see the oxygens aren't quite right. I tend to leave oxygen till last. Doing oxygen last is quite useful. In this case though, I'm going to make the oxygens balance as well. So to do that, I'm going to need another water. I've got 2 oxygens on the right side. I need 2 on the left side. So let's put in another H2O. I've run out of red. I'm going to use a pink one there to be oxygen. Okay, so I've got my carbons balanced and my oxygens balanced. Phew. Now, let's see how many hydrogens I've got. I've got 1, 2, 3, 4, 5, 6, 7, 8. Octahydrogen. And then I've got 9, 10, 11, 12 with the water. So let's see how many I've got on this side. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have got 12 hydrogens on each side. That means it's fully balanced. If it helps you, you can be a bit naughty and write C2H6O when you're doing your balancing. Okay, C2H6O, that's the same thing as we were doing at the start. And it will just help you not lose this extra hydrogen, which is where I think a few of you were going wrong on balancing this. Okay, so well done if you followed all of that. The next part is if I had 50 grams of butene and an excess of water, so I'm not going to run out of water, what mass of ethanol could I make? Right, let's go through that one. So just remember, at any time, feel free to pause the video and work this out along with me. Okay, this isn't just to show you what to do, it's to give you a hint, let you do a bit and then check your answer. So first thing we're going to do, we know we've got 50 grams, but that's all we know, and we want to find out how much ethanol we can make. So it's a really big question, isn't it? So the first thing we're going to do, we're going to check the equation balances. We've just done that, we know it does. 2 waters, 2 ethanols. So where to start? Start in the same place every time, and that is with the MR of the molecule. So I've got here C4H8. So 4 times 12 is 48, plus 8 times 1, that's 8. So we've got an MR of 56. Water, we've got 2 times 1, so that's 2, plus 16, so that gives me 18. And the MR of ethanol, we've already figured it out up here, is 46. There we go, 46. So how much are we going to have of the substance? So this is the MR of one molecule. How much are we going to have of the substance? So we would have, hang on a second. Sorry, I was just writing in the side bits there. So we've got 56 because we've got 1 lot of those. We've got 2 lots of water. Pause the video, figure it out yourself, check that I'm right. So 2 lots of water, that should be 36. And 2 lots of ethanol, so that should be 92 because it's 2 lots of 46. Okay, so what data do we have? We've got the mass, and that's 50 grams. Okay, so that's, if all you've done is this, you might already have got a mark or 2 on the exam. Okay, so if all you can do is this, don't worry too much. You can pick up the marks on the things like acids and alkalis, which most of you were pretty good at. But do always try these questions, okay? Because they are worth 4 or 5 marks, and the more of them you can do, the better. So, next step is always mass divided by the MR. Always do that. That gets you your ratio or your moles, whichever you want to say it. So let's see my calculator. Okay, and we have got 50 divided by 56. Mass over Mr. gets the moles, which is 0.893. Okay, 0.893. We've doubled it here, so we don't need to worry about halving it or whatever, because we've already done all of the jiggling about, as it were. So we're going to keep the same ratio. Okay, same ratio all the way across, because this is where you have jiggled your numbers. Okay, so some teachers will get you not to do this and say mass divided by MR. Oh, but that's double it, so you've got to do timesing and dividing and messing around. No, do it like this, nice and easy. I know it's not perfect, but it means that you're not going to go wrong later. Okay, so anyway, we've got this nice ratio, and we need to find out this missing number. So we are going to do the ratio times the MR. Okay, ratio times the MR. So back to our calculator. We've got our ratio still there. We're going to multiply it by 92. Okay, don't do it by 46 because you're only going to get half the number. You would have had to double this. I'm making it as easy as possible. The ratio's staying the same. We're going to do the MR of the substance rather than the molecule. Okay, so the ratio times the MR, so I'm going to times it by 96 and get 85.714. So that's 85.71 grams. Okay, now if you remember in the last video, I said a good way of checking would be to do 0.893 times 36 to get me 32.1 0.215. Okay, so if we do, that's not going to work out. Hang on a second. You know what? I'm really glad I checked, because 50 plus 32.15 does not equal this. It means I've gone wrong somewhere. So I went back to my calculator. I did 0.893 times by 92, which actually gives me 82.156 grams. Okay, 50 plus 32.15 is equal to 82.15. That works. So I think I put 96 in, didn't I, instead of 92? I hope you all shouted at me on the video that I was doing it wrong. But this is why I check. I always check, because that does equal. Okay, because if I've put the wrong number in my calculator, this means that I've checked it and I've made sure I have not got the wrong answer. So please do that for yourself. Okay, I hope that was really straightforward. I'm going to give you another question which is very similar. Okay, then you're going to work through it. You're going to pause the video, work through it, and then we're going to work through it together. Again, when we get to the point where you can't do it, watch what I can do to give you a start, pause the video, do that bit, and check to see if we were both right. Okay, so let's see what I'm going to give you. Okay, so here's an exam question that we can do together. Titanium is manufactured by heating titanium 4-chloride with sodium. Then it gives you an equation. And what we are asked to do is balance the equation and then say what mass of sodium is required to produce 1 kilogram of titanium. They are more likely to ask for a ton, but because why bother making just 1 kilo of titanium? But we're going to do 1 kilogram of titanium here because it's exactly the same method and we're more comfortable with kilograms. Kilograms will be for GCSE. Okay, so what's the first thing we're going to do? We're going to balance the equation because that's what question A says. So let's see what we've got. We have got titanium in green. And then we are going to have chlorine in purple. There we go, chlorine in purple, 4 chlorines on the reactant side, 1 on the product side. And finally, we are going to have sodium in gold. So we've got 1 sodium on this side and 1 sodium on that side. So looking at it, the titanium and the sodium are absolutely fine, but the chlorine isn't. And the only way that we are going to get 4 chlorines on this side is by multiplying the sodium chloride up by 4. So let's see what that looks like. Excellent. Now my chlorines are balanced, but my sodiums aren't. What am I going to do to make my sodiums balance? I'm going to have to multiply that up as well. So here we go. We have got now 4 sodiums. And let's see if that works. 1 titanium, 1 titanium. 4 chlorines, 4 chlorines. 4 sodiums, 4 sodiums. Balanced. Excellent. Okay, so now we need to do what mass of sodium is required to produce 1 kilogram of titanium, and we're going to work through it exactly the same way as before. So we're going to calculate the MRs, we're going to figure out what masses we've got, we're going to do our lovely mole ratio and times it by the MR and get the total mass of sodium that we need. Okay, pause the video, do that. If you're struggling, come and see what I'm doing. Okay, so here we go with the answer. What mass of sodium is needed? So we're going to do, I'm going to write it out again. Please notice, okay, this is my handwriting, okay? Titanium, when I'm doing chemistry, my handwriting is as close to the stuff that you are taught in primary school as possible, okay? Because that's really legible, and that means your examiner can read it and isn't, oh, is that an L or is it an I, is it a 1? No, please do it as legible as this. Okay, so forget about your handwriting and just make it as clear as possible. My A's stay the same because they're recognisable as A's. And it's easier to see that's an A and that's a CL, even if it's close together, that way as well. And again, the capitals, make them as capital as possible. I'm not doing very good on that, so titanium, there you go, nice big capital. And for NaCl. Okay, oh, that might be an I. Let's make the L a bit bigger. Okay, so an examiner can read that really easily. That's where you get some of your marks from, guys. So anyway, what mass of sodium is required to produce 1 kilogram of titanium? Let's figure out the MRs first. Okay, so look it up on your periodic table. I have sent you a periodic table before. I will be sending it again with this video. So if you're in my class, you've got it. If you're not in my class and you're just watching and enjoying, go to whichever exam board you're doing. Go to the chemistry or the combined science. Go to the past papers, and there will be either, so if you're doing AQA, the periodic table comes as a separate handout. If you're doing Edexcel, it comes on the back of the question paper, so you'll have to download an exam paper, and the very back page is your periodic table. Okay, don't use a periodic table that you've randomly picked up somewhere, because then you'll get one that looks different in your exam, and if you get one that looks different in your exam, you might have a minor panic, and I want you to be as familiar as possible with it. Okay, so anyway, looking it up, titanium, Ti, atomic number 22, mass number, it's going to say 48 on your periodic table. So I've got 48 plus 4 lots of 35.5. Again, it is quite useful to know these, but I'm really not expecting you to. 48 plus 4 lots of 35.5 gives me 190. Okay, so let's just check. 48 plus 4 times 35.5. So I've not messed up my calculation this time. 4 lots of sodium is 4 times 23, which should give me 92, and it did. So for those of you who are watching this as an A-level recap, you never know, you might do. I know that your numbers will be slightly different because you go to 1 decimal place usually. Do your own calculations for this just based on what I've shown you. Okay, and it's going to make titanium, which we've just looked up. It's 48. And 4 lots of sodium chloride. So that's 4 lots of 23 plus 35.5.
Mommy, do you need this away?
Yes, please, darling. So I've got Theodore helping me again. He's absolutely brilliant. So 4 lots of 23 plus 35.5. And that gives me 234. For those of you who are doing the higher papers, you do have to get used to standard form looking like that. 234 is acceptable, but you are supposed to know that 2.34 times 10 to the 2 is 234, which is why the calculator is in standard form, just to help you a little bit with that. So anyway, we've got the MRs, and now we need to know the MR of the substance. So MR... So 1 lot of titanium chloride, that's going to stay at 190. 4 lots of sodium. Oh, I've already done it. Sorry. I've already done the MR of the substance.
All the Lego away.
Thank you, Theodore.
This has to go away.
No, it doesn't. I need that. Okay, so I've already done that. That's the MR of the substance. because I've already times my 23 and my 58.5 by 4. Okay, so next thing to do is, what do we know? What masses do we know? Well, all we know is we need 1 kilogram of titanium. Okay. So that's 1,000 grams. Okay, we need to convert it all to grams because we work in grams in chemistry. Okay, to get our ratio, mass divided by the MR. So that is 1,000 divided by 48 to give me 20.83. Okay, this is our little ratio that we're going to use. We need to know how much sodium. So this number is going to be the same all the way along. Okay, so then what are the other masses? So we are going to do the MR times by this ratio, these lovely moly ratios, okay, and what that should give us the mass. So 20.83, here we go with the calculator again, 20.83, okay, now 3 is recurring and I can do that on this calculator, and we're going to times it by the MR.